this video, we're going to dive into trigonometry. Now, before you start thinking, oh no, not triangles again, let me show you how trigonometry can actually be pretty cool and super useful. This video is going to focus entirely on just finding missing sides. When you come to finding missing angles, please watch the relevant video. Trigonometry is all about the relationship between angles and the sides of a right-angled triangle. When you have a right-angled triangle, the longest side is always the hypotenuse. It's the one that's opposite the right angle. The other two sides are known as the opposite and the adjacent side. Now, depending on which angle you're looking at or is involved in your question will depend on which of the sides is the opposite and which is the adjacent. So in this example, the opposite side is here, opposite the angle that's involved in the question, and the adjacent means next to it. So it's the side that's next to the angle, but that's not the hypotenuse. But if I swap this angle over to the other corner here, notice that the sides change. So now our opposite is opposite this angle and our adjacent is next to it. The hypotenuse is always going to be the hypotenuse, so it's usually the first one you should label when you start practicing trigonometry. So here's where it gets fun. To help us find missing sides, we're going to use something called the trigonometric ratios, and those are our sine, cosine and tangent ratios. Now, we can use a word also known as SOHCAHTOA, and it's a really handy way to remember which side to use. So if you look at the word SOHCAHTOA, it's a group of lots of three letters. And the first three letters are telling you how the sine ratio should work. So it's saying the sine of the angle should be equal to the opposite divided by the hypotenuse. The second set of three letters, CAH, stand for the cosine ratio. So it's saying the cosine of the angle should be equal to the adjacent side divided by the hypotenuse. And the third of these groups is TOA, and that is saying that the tan of the angle is equal to the opposite divided by the adjacent side. Okay, and you can set out these little triangles, as you can see to the side there. The middle letter would be always at the top, and this helps you work out exactly what you need to do to solve any trigonometric questions. Let's work through a quick example. Okay, suppose we have a right angle with an angle of 30 degrees. And we know the hypotenuse for this triangle is 10 centimeters, as you can see. We want to find the length of the opposite side, okay, which is marked with an X here. We can use the sine ratio because this question involves the opposite side and the hypotenuse, okay. There's nothing to do with the adjacent side at all. Therefore, we would choose the sine ratios, the first group of three letters. Right, now that we have all of our components, what we're doing really is substituting into the triangle that we had before. So cover up the item we're looking for. So we're looking for the opposite side. So cover the opposite side up. And you can see that we're going to do sine of the angle times by the hypotenuse. So that's 10 lots of sine and the angle is 30. Okay, pop that straight into your calculator and press equals. And you should find out that the missing side X is equal to 5 centimeters. Easy as that. Okay, let's look at another example. In this example, you can see we have a triangle with an angle of 35 degrees marked. And we now have to figure out which sides are involved. So we've got an 8 centimeters, that is on the adjacent side. And we've got X, which is the hypotenuse. So that's what we're looking for. So A and H are together in the middle group of three letters. So we're looking at the cosine ratio. Again, we know we've got 8 for our letter A, and we've got 35 for our angle, which is sometimes called theta. That's that symbol you can see there. So we're going to pop in cosine 35 is equal to 8 over x, but of course we're going to have to do a little bit of rearranging of that formula because I want to make x a subject. So to find x, I'm going to do 8 divided by the cosine 35, and that tells me that our hypotenuse length is 9.77 centimeters long. In our final example, you can see we've got a triangle with an angle of 50 degrees, and we've got two marked sides. One is the opposite, and that's marked with a 9-meter value, and then we've got x, and that's going to be the adjacent. So again, no involvement here with the hypotenuse. So the group of letters we're looking at is the last group. So we're looking at the tangent ratio. Right, again, pop in what we know. So we know the opposite is 9, and we know the angle is 50. Check to see if we need to do any rearranging, and we do for this one. So we're going to have an x is equal to 9 divided by the tan 50. Pop that into a calculator, and that will tell you that the x value on this triangle is 7.55 meters long to 2 decimal places. Well done. Okay, now that you've got the hang of identifying the different sides and identifying the correct ratio, you should be able to work out any missing side on a right-angled triangle using your trigonometry.